Hello everyone. In this video we're going to be solving a nice homemade exponential equation. We have 1 plus x to the power 1 over x equals 4, and we're going to be solving for x values. Great, so we're going to be looking at a couple different things here. We're going to differentiate this function, we're going to look at the limit, we're going to look at a graph, and we're going to use the natural log. First of all, let's start by taking the natural log of both sides. So that's going to give us a better idea. And now we can go ahead and move this 1 over x to the front by using properties of logarithms. So this gives us 1 over x multiplied by 1 over x multiplied by ln 1 plus x, which is the natural log of 1 plus x, equals ln 4. And then this the left-hand side can be written as a quotient, ln 1 plus x divided by x equals ln 4. So wouldn't that be nice if the ln's had the same arguments? So that implies 1 plus x equals 4 or x equals 3. But when you plug in x equals 3 on both sides, you're going to get ln 4 divided by 3 equals ln 4. ln 4 does not equal 0, so this is false. In other words, x equals 3, trial and error, gives us that it's not a solution. So x equals 3 does not work. We could probably take a note here, x does not equal 3. So we just wanted to, do one-to-one correspondence, but it didn't work. So we kind of need to dig deeper. How about writing 4 as a power of 2 and going from there? So ln 4 can be written as ln 2 squared. So let's go ahead and do that. ln 1 plus x over x equals ln 2 squared. And that can be written as 2 times ln 2. Now here I have a quotient, here I have a product. So I have to turn this product into a quotient, but that can be done by using the reciprocal. Multiplying by 2 is equivalent to dividing by 1/2. So now wouldn't it be nice if x was 1/2? Is that possible? If x equals 1/2, then you're going to get 1 plus 1/2 here inside the parentheses. That is going to be ln 3/2 divided by 1/2. Is that equal to ln 2 divided by 1/2? If you forget about the 1/2, it means ln 3/2 is equal to ln 2, but that's not true. They're not equal. So x equals 1/2 did not work either. So we did 2 trials and they were both errors. Trial and error, that's what it's called. Okay, so we need to do something else. But all hope is not lost, hopefully. How about, this kind of tells me we had to get a product, but maybe use a fraction instead. How about writing the 4 as square root of 16? We could try that. ln 1 plus x over x equals ln 16 to the power 1/2, and then move this over here, and you're going to have a 2 at the bottom. X equals 2 is not going to work because 1 plus x is not going to be 16 because x is not 15. Make sense? Quickly check that x equals 16 is not going to work. So 1/2 power is not going to work. My only option probably is to go with a different approach, and that is going to be a negative number because I have a 1 plus x, but I have x here. So 1 plus x hopefully can be made smaller by using a negative number. And how can we achieve that? So here's what we're going to do. Finally, we can write the 4 as ln 2 to the power 2. But instead of 2 to the power 2, I want to write it as 1/2 to the power negative 2. Does this make sense? In other words, 4 is 2 squared, but 2 is 1/2 to the power negative 1. And then if you multiply the exponents, you get 1/2 to the power negative 2. So that's what the negative power does. And is this going to work? We don't know. Let's find out. Move the negative 2 to the front. That's going to become a negative 2 times ln 1/2. It still doesn't work because we have to make it a quotient. But we can do that easily. ln 1/2. And let's put that in parentheses to avoid confusion. Divided by negative 1/2. So now I have something much, much nicer. And take a look. This equality is going to give you an answer. Because if x is equal to negative 1/2, then 1 minus 1/2 is 1/2, so everything works. Yay, nice, I found the solution. X equals negative 1/2. I didn't want to start with something that works because if you know the answer, you know the answer, but if you don't, then you're gonna try and fail sometimes. Anyways, x equals negative 1/2 works, but is that the only solution? What kind of function are we dealing with? So let's write f of x as, how about this? That's the natural log, so I want to look at the original one, 1 plus x to the power 1 over x. Is this always increasing or decreasing, or does it have a maxima or minima? So we can write 1 plus x to the power 1 over x as e to the power ln that, and then we can move this x to the front as a quotient, so we can kind of write our function in a nicer form because this will be easier to differentiate, so on and so forth. So if the exponent is an increasing function, then e to the power increasing function will also be increasing. Otherwise, it is going to be decreasing. But take a look at this. I have ln on top, x at the bottom. The polynomial is going to grow faster. So this is actually going to be a decreasing function. So f of x is decreasing. But I also want to take a look at something else. Are there any asymptotes? There seems to be a problem at x equals 0, because if you look at it, that's going to make our expression kind of undefined or indeterminate. So we should have an open dot at 0. Also, if you check limit as x approaches infinity of f of x, let's see what happens. E to the power, that's going to be the limit as x approaches infinity of e to the power ln 1 plus x over x. Let's take a look at this. This is kind of like infinity over infinity, so I can use L'Hopital's rule. If you check ln 1 plus x over x, this is going to be, when differentiated, this is going to be 1 over 1 plus x, and x is going to be 1. Remember, we differentiate the top and the bottom, not the quotient rule. And as x approaches infinity, this is going to approach 1 over infinity, which is 0. So e to the power 0 is just going to be 1. In other words, our function is going to approach 1 as x approaches infinity, which means we're going to have a horizontal asymptote. Under all these conditions, let's go ahead and take a look at our graph, and we'll conclude with that. And we got one solution, x equals negative 1/2, and our function, our graph, is always decreasing. As you can see, we should have an open dot at 0. Unfortunately, Desmos doesn't show that. Too bad. But x equals negative 1/2 is the only solution to this equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.